So now let's just have a quick look back on how the different standards or specifications came into realization. So let us look what are the relationship between the specifications and the different bridge failures that happened in the past. For most bridge engineers, it seems that bridge specifications were always there. But that is not the case. The early bridges were built under a design build type of contract. The bridge company basically wrote its own specifications when describing the bridge it was proposing to build. As a result, depending on the integrity, education, and experience of the builder, some very good bridges were constructed, and at the same time, some very poor bridges were built. So today, on this modern time, we design highway and bridge structures with the guiding principles coming from the different design standards that we usually refer to. But before, in the past, most bridge engineers actually uh, build highway and bridge structures without the aid or help of the specifications that help us to design and build today. So on those previous times, it was just solely a design build type of contract that is happening on those highway and bridge structure projects. So when we say design build type of contract, there is only a bridge company that will provide his or their own design. There is only a one company, bridge company, that will provide their own design, and then there will also be the one to build the design that they have made. So therefore, the different specifications for the design will obviously be coming from the bridge company itself, or should I say the builder itself. So therefore, the specifications will solely base on the integrity, education, and experience of the builder himself, because he is the one who produces their own specifications. So there is no design standards at that particular time before. There's no design standards or design codes that were being used as a guide for designing and constructing bridge structures on that particular time. So the specifications will be were just coming from the bridge company or the builder themselves. Therefore, there's no standard specification. Each builder will have their own specifications that will and the quality of that specification will mainly depend on the integrity, education, and experience of the builder himself. Therefore, there are some very good bridges that were constructed, and at the same time, there are very poor bridges that were built. Of the highway and railroad bridges built in the 1870s, one out of every four failed, a rate of 40 bridges per year. The public was losing confidence and did not feel safe when traveling across any bridge. Something had to be done to improve the standards by which bridges were designed and built. So because of that, since there is no standard way to design and construct bridges or highway bridges projects, therefore, as a result of that, since there was no a standard for designing and constructing bridges, the result is having a a bridge structure or bridge structures that have different quality. So some of them were built or built in a with a high quality, and some were built with a not so good quality. That therefore resulting to some bridge failures that happened in the past. So because of those failures happening on those bridges that were built by different specifications coming from the different builders, the public was losing confidence and and the design professionals at that particular time, the bridge engineers, felt that there is something that to be uh, that needs to be done to improve the standards by which bridges were designed and built. And as a result of that, on December 12, 1914, the American Association of State Highway Officials, or AASHO, was formed. And in 1921, its Committee on Bridges and Allied Structures was organized. The charge to this committee was the development of standard specifications for the design, materials, and construction of highway bridges. These specifications have been reissued periodically to reflect the ongoing research and development in concrete, steel, and wood structures. In 1963, the ASHO became the American Association of State Highway and Transportation Officials, or AASHTO. So this is the current logo of AASHTO, the American Association of State Highway and Transportation Officials. So as you can see on their logo, they were founded way back 1914. So before, the name of the organization was American Association of State Highway Officials, or AASHO. But later on 1963, the organization's name was changed to AASHTO. So the word transportation was incorporated to the name of the organization to emphasize that the organization is not only the governing organization for the specifications for the highway and bridge construction and design, as well as they also include the design and construction of all modes of transportation. So that is the reason why the word transportation is included or was included on their organization's name, to emphasize that they are not only covering highway design and construction, like just like what their previous name manifested, but also they are also covering all modes of transportation, not only highway, but also the other modes of transportation: air, land, water, and railway transportation, not only highway, but all modes of transportation. So it's for the uh, emphasis that they are the governing organization for all modes of transportation. So this is the organization formed before to address the losing confidence of the public on the bridge structures that were built on that particular time. So this organization was tasked to provide a standard specification for the design, materials, and construction of highway bridges. But then again, as their current name manifests, they are not only the governing body for highway only, but also on the other mode of transportation. So they became the solution to address the problem of bridge failures that happened in the past. For railroad bridges, this task began in 1899 with the formation of the American Railway Engineering and Maintenance of Way Association, or AREMA. So this is their logo. So their main tasks already began way back before the AASHO were formed or was formed. So they were tasked to address the problem for railroad bridges way back 1899. So that is the AREMA. This is an organization that is mainly focused on railroad bridges. Specifications are constantly changing and adapting to new developments in the practice of bridge engineering. Just like what I've said before, the standard specification that were published by AASHTO were constantly updated periodically. So that update is actually the result of new developments in the practice of bridge engineering. Although in some cases, new information on the performance of bridges was generated by a bridge failure. Several lessons have been learned from bridge failures that have resulted in revisions to the standard specifications. So it's not only the new developments in the practice of bridge engineering. Uh, is- uh, it's not only the new developments that were the reason for the revision of the standard specifications, but also because new information can also be generated uh, from the from the bridge failures that happened in the past. So aside from the new informations or new information that can be generated from the research and development, new lessons as well can be generated from the lessons that we have learned from the different bridge failures that happened in the past. So this new information that we have gathered from research and development and from the bridge failures that happened in the past were incorporated to the standard specifications that were being published by the different organizations, so that these bridge failures that happened in the past will not be happening again uh, after we already learned our lesson on that particular bridge failure, after we have learned what uh, what might be the cause of the failure of a certain bridge. So the one of the most famous bridge failure that happened in the past was the Tacoma Bridge. So this is the Tacoma Bridge, a bridge that was not perfectly designed to resist swaying. So as you can see here on the GIF, the bridge was constantly swaying back and forth, even though there is no vehicle load that is or that was traveling on it. So because of that swaying, it led to the eventual or sudden collapse of the Tacoma Bridge. So the lessons that we have learned from that particular bridge failure and other bridge failures that happened in the past were incorporated to our standard specifications. So revisions on those specifications were made so that the lessons that we have learned from the bridge failures that happened in the past will be incorporated on them, so that we will not experience the same bridge failure again. Most of the memorable bridge failures and the ones that most affect bridge engineering practice have occurred in structures that were in service for many years. However, in-service bridges are not the source of the most common occurrence of failures. Most failures occurring during construction, uh, Most failures occur during construction and are likely the most preventable kind of failure. So, aside from the bridge failures that were experienced by those bridges that uh, were already standing for several years, bridge failures also occurred during construction. So not only erected bridges experience failures, but also those bridges that are still on construction stage. So those bridges that experience failure during construction again gave us a very hard lesson that provided us new information to the performance of bridges. So again, those lessons were incorporated to our standard specifications, so that we will not experience the same failure again on our bridges that we design presently or currently in the industry. So as we can see there are actually a relationship between the specifications that we are using right now and the different bridge failures that happened in the past. So these different bridge failures that happened in the past gave us new information about the performance of bridges. And this new information, together with the new information gathered or collected from the new developments in the practice of bridge engineering, were incorporated on our standard specifications, thereby resulting to revisions of these standard specifications that we are using currently. So if you want to know more about the different specifications that came as a result of different bridge failures, you can refer to Chapter 2, Specifications and Bridge Failures, from the book of Parker and Paquet, entitled with the title Design of Highway Bridges, 3rd edition.